Okay, what I wanted to do now today was derive the power reduction formula for the integral of cosine to the n of x dx. And so the use of this is when we have a large power of n, so maybe this is cosine to the 8, or maybe it's cosine to 100. We have a formula where we can reduce the power, get it in the form of another integral. We're only reducing the power by 2, so it's an iterative process. So let's get started with this. So what I want to do is I want to just call my original integral I sub n so we can kind of keep track of it. To start this off, what I'm going to do is I'm going to rewrite my integral. We'll write this as cosine n minus 2x, and then we'll write a cosine squared x, just noting that we haven't changed it because we multiply cosine squared times n minus 2, we get back to cosine of n. Then I want to represent this, let's write this as 1 minus sine squared x. Okay, and then let's rewrite this. But what I'm going to do is I'm just going to distribute this in here and separate it into two integrals. Okay, and then the thing I want to notice here is we have our reduction in place right now, because this is actually going to be I sub n minus 2. So we're going to keep this, and this is going to help us. This will be our reduction step. We don't want to have another integral in here. We want to actually solve this one. Now, if this was just a sine, we'd be fine, because we could do a u substitution, but we have a sine squared. So what I'm going to do to handle that is let's use integration by parts. We'll use the DI method, and we'll break this up so that we can still do a u substitution, but only on our integration part. Okay, so setting up our tabular integration as a shortcut for integration by parts, I just pulled the sine out, so we'll differentiate a sine here. In doing that, we're going to have cosine of x. And then I chose to integrate the rest of it, which is cosine n minus 2x sine x. This will allow us to use this u substitution. I'm going to write this as a minus sine x and a minus in front here. So then, if our u is cosine x, then our du is minus sine x dx. So I think we can see what this is going to be when we integrate this. Doing that u substitution, using the power rule, we're just going to get back cosine n minus 1x over n minus 1 here. So then rewriting our integral, our I to the I sub n expression, we're going to have this piece being I sub n minus 2. Then we're going to have this diagonal, but we're subtracting, and there's a minus here. So minus times minus plus, we're going to have sine x cosine n minus 1x all over n minus 1. Then this next line is going to be, we're going to integrate this, but we have a minus and a minus, that's a plus, but we have a minus in front. So we have minus this integral, which is going to be n minus 1 in the denominator, dx. When we multiply cosine, that's a cosine to the 1x times cosine n minus 1, we just end up with cosine to the nx. And then what I notice here is this expression looks really similar to our original integral. So we can write this as I sub n, but over n minus 1. Now what that's going to allow us to do is it's kind of like the repeat integration by parts process, where we end up just trying to solve for the original integral, just doing like basic algebra. And what we can do, since we're subtracting this thing here, we can add the same thing. So we can write it like add I sub n minus 1. Just do the same on both sides. And then so let's just look at this expression right here and see what's happening. So if we say I sub n plus I sub n over n minus 1, we can pull out the I sub n and write it as 1 plus 1 over n minus 1. But then getting a common denominator, we're going to have n minus 1. Let's see, let's write this out. So n minus 1 plus 1 over n minus 1. And so this whole thing is going to be I sub n minus 1 plus 1 is just n over n minus 1. Okay, now just continuing from where we left off on the previous board. Remember what we're trying to do. We want to solve for I sub n. And so let's just try to isolate this. Let's multiply n minus 1 over n on both sides. We get the nice cancellation, so we've isolated it, but we need to do the same over here. So we're multiplying by n minus 1 over n, distributing it in here. So for our final answer, for I sub n, we're going to have n minus 1 over n distributing to this term, I sub n minus 2. Then when we distribute it here, we get the cancellation. So we're left with sine x cosine n minus 1 x all over n. And so that's going to be our formula, our power reduction formula for cosine of n. I think what we'll do is get into how to use this in some other videos. Thank you for watching. Please like and subscribe. Have a good day.